Hi everyone, in exercise 3 and 4 we will see some easy and concrete examples of tensor product. In the script this topic appears at the last section, but the notes are a bit more abstract than the exercises. That's why I sent some additional hints. But here we only consider the tensor product can work in a simple case. There can be different way for solutions, but for now I'm going to present my way. In this exercise, we have two-dimensional vector space over finite field F5, and we know that this vector space has two bases, like standard bases. Again, like in exercise 2, we have images of base of tuples here under a map F. In the first part, we want to get a multilinear map from given F. So for the solution, we only use the multilinear definition. That means for two vectors A and B from the vector space, we want to determine this multilinear map T, and as a first step, like in the exercise 2, we consider the linear expansion of the vectors with respect to the given vector space. And here note that this AI and BI from the finite field F5, and these are the vectors from V. And as a next step, we apply the multilinearity definition. This gives us A1, B1, T of E1, E1, A1, B2, T of E1, E2, plus A2, B1, T of E2, E1, A2, B2, and T of E2, E2. And here, we know that these images are determined by the F. We only plug in the definitions, given values. This is 1, this is 4, and this is 0. And we see that actually this multilinear map is determined by this equation. You can check the multilinearity. Check, this is multilinear, by the definition. And so far we didn't use any property from finite field, but in the computation of the images of vectors 2, 3, and 4, 1, this is going to be A1, A2, this is going to be B1, B2. With this notation, we compute 3 times 2 times 4, 2 times 1, 4 times 3 times 4. And here the finite field is given by a prime number. It will be important, but it's enough to know for this question. It's going to be 4. This is a prime. You may compute it modulo 5, and I hope that this is a 4 if there is no calculation mistake. For the second part, I want to put some comments on the tensor product over this exercise. And thanks to tensor product, we will get a linear map S from a multilinear map. So just brief note, if we have any map from a vector space Cartesian product, the base field, if you write the definition, multilinearity and the linearity, they don't work in the same way. So it can be nice exercise, nice observation for you. But here we have multilinear map, and to see that S is induced from S, first we want to observe how the bases behave. For this purpose, in the hint, we consider another map which gives an information about the images and particularly basis for the tensor product. And we can find again by the definition of tensor product, these are the two tuples, the vectors. We consider here the definition of tensor product as the matrix multiplication. And this allows us to compute a basis for this vector space. And I will show the indices depending on the indices of the given basis. And this is 1, 0, 1, 0. It's going to be 1, 0, 0, 0. And similarly, second basis will be tensor product of E1 and E2. 1, 0, 0, 1. It gives us this base element. And actually we need to compute two more base elements because this vector space is of dimension, will be of dimension 4 because each one is dimension of 2. And for the third one, we get 0, 1, 0, 0. And finally, we have this element. And here note that actually this element, we saw these elements as the basis for 2 by 2 matrix space. And coefficients will be from F5 in this example. And here we want to compute for any X and Y, the images of F. We want to determine this linear map. So this is S of X transpose times Y, again matrix multiplication. It gives us X1, Y1, S of E1, E1. And then of course we will expand this matrix This is x1, x1, x2, y1, x1, y2, and x2, y2. And we simply write this matrix with respect to this given basis, the basis we compute. And it's going to be x1, y2, s of e1, 2. x2, y1, s of e sub 2, 1, and x2, y2, s of e2, 2. And only consider this basis element and the correspondence between the t, because here, just again a brief observation, we have a multilinear map here, T, and we consider another map G, and we want to get S. And we view this actually as a commutative diagram, and S is going to be S composition G. And that means the images will be determined by in this way. So we simply plug in the images of the bases, which is given like this. x1, y2, and for x2, y1. And that means actually S is a linear map which maps a basis 3 times the first coordinate plus second one plus 4c, and check that this is linear. So that means any matrix A and B and the n scalar, we have this property. Okay. And finally, for this question, it is asked to compute the kernel. And we know how to find the kernel of a linear map. And this kernel can be represented as a set as 3 times b plus 4b is equal to 4. And here again we consider the finite field arithmetic if you want to compute these entries explicitly. And for the first case, consider A equal to 0, B0, C0 gives us one solution. If C is 1, we have 4C. So 4 times 1, 4 in F5. So if you consider the 1, 1 plus 4 will be 0. This is again in the kernel. And similarly for 2, 2 times 4, 8, but modulo 5 it is 3. And if B is 3, we get again another element in the kernel. And for A equal to 0, we get this solution. And similarly for the second case, consider A as 1. And for when C is 0, this is 3A. It's going to be 3 plus 2 gives us 0. And for if C is 1, it's going to be 4. 4 plus 3 is 7. Modulo 5, it's 2. So it gives us B as 3. And similarly, we continue this observation to find the values of ABC, the entries of ABC explicitly. And here note that in this equation we don't need D. So this is why it's going to be enough to analyze only the entries A, B, and C. And in the solution key, you can also see for the other cases when A is equal to 3, when A is equal to 4, and that will be enough. And if you write to kernel S, whose contains the matrices which makes this equation 0, we may simply write 0, 0, D for any value D from F5, we get these matrices by only plugging the values here, A, B, C. And you can see the full solution in the solution key. And that's all what I want to say for this question. See you in the next video. And if you see any mistake, please don't hesitate to tell me.